So there's a common molecule that we find in organic chemistry called benzene, and that has a formula of C6H6, and it's simply a ring with alternating double and single bonds. It's also drawn with this circle notation, and that basically indicates that the double bonds resonate around the entire molecule. And so the pi electrons in those double bonds are equally shared around the ring. So that's why there's a circle there. So to name it, we just use the name benzene. We don't need to use the actual full-out name cyclohexyl-1,3,5-triene. Because this is so common, IUPAC has actually designated benzene as the official name of this molecule. And so if there's substituents on it, we just name it like we would any other root. So in this case, 3 substituents. We start here to minimize the index, 5, 6. And so to name it, we have to go alphabetically. So nitro comes first, so 1 nitro. And then we have 2 propyls on 2 and 4, dipropyl. And then the root is just benzene. And that's it. And so benzene is so common that there's actually convention on how to name specific benzene type molecules. Disubstituted benzenes are so common that there's actually a nomenclature that's been adopted for the position of the 2 substituted elements on the benzene. So if it's 1,2, we call it orthobenzene. If it's 1,3, we call it meta. And 1,4, we call para. So for example, if I'm told that I want to draw p-dichlorobenzene, what would that look like? Well, we have a benzene. P stands for para, which means 1,4, and that just means that the 2 chlorines are opposite each other. That's para-dichlorobenzene. Or M-bromo-ethoxybenzene. Again, benzene is the root. And then M stands for meta, or 1,3. And so that just means that we draw ethoxy on one side. It doesn't matter which. And bromo on the other side. It doesn't matter because benzenes can be flipped over. They're essentially flat molecules, so it doesn't matter which direction I draw the 2 substituents. So how would I name these using the original IUPAC names? Ortho, meta, para are not IUPAC nomenclature. Benzene is, but these designations are actually just so common that it's useful to know them. So how would we name them in IUPAC nomenclature? We would just substitute the P in this name with what it means, 1,4. And so we would call it 1,4-dichlorobenzene. And for meta, we have to be careful. 1-bromo, because now we have to be careful about the alphabetical order. So 1-bromo, 3-ethoxy, benzene. There you go. Now, what if the molecule gets so complicated that the benzene has a bunch of complicated substituents coming off of it? Well, sometimes it's actually practical to turn benzene into a substituent instead of being the root. In this case, IUPAC actually says that you can make benzene the root or the substituent, depending on the complicatedness of the substituent coming off of it. You don't have to look at the length of the substituent chain versus the benzene. You basically just pick whichever one is less complicated to make it the root. So in this case, phenyl is the name of benzene as a substituent. Benzyl, or phenyl methyl, is the name of benzene with basically a carbon connector in between it and the backbone. So here are a couple of examples. 2-phenyl, 1-hexene. Now, this nomenclature is something that I didn't show you before, but you can actually have the index come before the name, instead of being in the middle, hex 1-ene, they essentially mean the same thing. So I'll draw the backbone first. So hexene with a double bond on the first position. And then 2-phenyl just means that there's a benzene coming off of position 2. Like that. And then 1,5-diphenyl pentane. Well, the root is pentane. 1,5 just means that there are 2 benzene rings or phenyl groups on both ends. Like that. So in this case, it's easier to name the pentane as the root, because otherwise you'd have to pick one of the benzenes and then name a substituent that has a pentane group and a benzene in it. Again, with IUPAC naming, it's equally correct to make benzene the root or a substituent, depending on what makes the naming easier.